Well, the Air Force is currently rewriting criteria for blast-resistant construction. And the data that's obtained from this program will factor into that very heavily. And we'll be able to establish new limit states for the construction in extreme events, such as a blast. And that will be very helpful for us in designing and planning for future construction on military facilities. Some of the criteria that the military has been using for construction of facilities has been overly conservative, that our ductility ratios and our allowable support rotations have perhaps been over conservative, and this information will help us to fine-tune that, and that will allow us to develop new standoff criteria perhaps, or even increase levels of protection for the types of construction that we're testing.
This research program was started, I think, in about 2004 to look at conventional concrete wall construction used in the United States. This particular test we're looking at right now is sort of the culmination of the last 3-4 years of work that we've done. We've looked at different panels statically, and now we're looking at them under dynamic loads, primarily to look at the performance of panels under blast loads, particularly from threats such as car bombs and anti-terrorism force protection type applications.
What we're looking at here is all military construction, for example, has a requirement for anti-terrorism force protection. A lot of the military designs now say if you have a certain distance away that you can protect against, you can build your structure out of virtually anything according to the building code. You can't always get that standoff distance. What we're trying to demonstrate here is that these wall systems can be built economically inside the minimum distance requirements and still provide viable protection for federal structures.
A lot of the criteria that was written for designing these types of systems was before the sandwich wall panel was really introduced into the market, and some of the criteria is as old as the 40s and 50s. What we want to do with this program is to rewrite design methodology for the future, take in the new technology, and to minimize the costs. We're really trying to bring all that in together.
If everything goes as planned, then we, I believe, are going to be opening up a new market for the precast concrete industry, especially in the sandwich wall panel industry, where in the past we may have been limited in the market because of the lack of data. With this additional testing and additional research, now the Air Force, the government, other military organizations have data on pre-stressed concrete products, which in the past they've never had.
This research is very exciting for the precast industry. Now that we're generating the data and we're actually validating some models, we should be able to use all of this knowledge to really push precast as a viable, cost-effective alternative for blast protection.
The next step really is to go into existing facilities or existing types of construction and look at how to retrofit those facilities and make them stronger. We also need to look at how do these panels do when there's openings with doors and windows? Is there anything change? Any failure modes that are different? And then the final thing would be to look at these as a whole facility and look at if a complete structure was made out of these panels or of this type of a system, would we have any other issues that we are not aware of, and how would that work? Those are the future direction of the program that we'd like to take it.
This is the type of thing that we are very happy to participate in. It's of great benefit to DoD. I think it's a great benefit to the industry and to our profession to be able to have a part in doing research that potentially saves lives.